Hey guys, welcome to your Chapter 3, Lesson 5 notes. Today we're working with sets. By the end of the day, you'll be able to do 3 things. First, you'll be able to write a set, and then you'll be able to identify its subsets, and finally you'll be able to find the complement of a set. Now that's great, but in order to get set and go, you need to figure out, you need to find out what is a set. Well, I'm going to tell you, a set is literally a bunch of things. It's a collection of distinct elements. It's when you have things together. Often sets will be in these like braces. Okay, right? The numbers 1, 2, 3, 4, 5, 6. There you go. Or the results of flipping a coin. We get heads or tails. Or just the students in a class is a set, right? You're all separate people. Okay? And then a subset is a set within a set. So we could have like the even numbers from our first set. That's a subset. It's a set of numbers within another set. Or we could have like the set of just the boys in our class. That's a subset of students in our classroom. Okay, right? So there you have it. There are a couple different ways to show what is in a set. The first one is called roster form. Roster form is like when you take attendance, you look at the roster of who's here. That's literally, you just list it. You list the elements of the set. You write them all out. So you list the elements of a set. Right? That's roster form. An example of what roster form might look like is literally the attendance list. Who's attending our set today? So roster form is this kind of thing. When you're listing out everybody, 1, 2, 3, 4, 5, 6, that's roster form. Another way to write is set builder notation. It's basically giving instructions on how to build your set, right? So it's just saying, hey, all the numbers that are like this, all the numbers with this property or these properties, those are going to be in your set. So when you describe what's in your set, that's set builder notation. When you're just listing what's in your set, that's roster form. So an example of what set builder notation is when you have like all numbers x where, this guy means where, or such that, or as defined by, or whatever. Where x, that's an x. Come on. X is an even number. That's totally fine. That's set builder notation. So let's practice. Let's do one way of writing a set in roster form, and let's do another way of using set builder notation to define a set. So how can you say T is the set of natural numbers that are less than 6? Remember that natural numbers is, big N. Natural numbers are things like 1, 2, 3, 4. They're your counting numbers. They're numbers that my 4-year-old niece includes with all the numbers. And then less than 6. Remember, if a number is less than 6, that's like that. X less than 6. Okay. So in roster form, if we want to list all of these numbers, that's 1, 2, 3, 4, and 5. Those are all the numbers. Ta-da! You also can do set builder notation where we just describe it using these identities. So set builder notation would give us all numbers x where x is a natural number, and then we'll need to add a little comma. X is less than 6. And then we'll need to scoot over because we ran out of room. If you want to get ultra fancy, You can use this N guy, which means the natural numbers. Okay, this is like super bonus, extra fancy. And you would say, so I need all numbers X where, and then here's where the fancy next gets in. There's an extra little tool you'll need. This guy, that means is in, like included in. So you say X is a natural number. X belongs in the natural numbers. Also, X is less than 6. So you do not need to know this at all. This looks like an alien language. It's a foreign language of mathematics. But there you go. If you just want to write it out, you write it out. That's great. In this case, roster form is easier because it took a lot less to do. However, that will not always be the case. Like in example 2. How do you write out all the solutions of this guy? Well, first we need to solve it. So let's solve it real fast. We're going to subtract 7 from both sides, giving us negative 5x is less than or equal to 10. I like 10. And then we're going to divide by negative 5. And then we do the x, negative 2. So x is greater than or equal to negative 2. Phenomenal. But we need to use this in set builder notation. However, we basically have already. So all the solutions are, so let's do our curly brace, x where, ready? It's just this. X is greater than or equal to negative 2. And that's our final answer. Isn't that great? And we can also represent these guys on a number line if you wanted to. Greater than or equal to negative 2 is all these numbers right here. So it's negative 1, it's 0, it's 1, it's also negative a half. There you go. So isn't that fun? So fun. Now sometimes, here's a big mind blow. You can have what's called the empty set. Now the empty set is exactly what you would expect it to be. It's a set with nothing inside of it. It's empty. It contains no elements. There's nothing inside of it. So you can just write it like this. You can just do an empty set, or you can use this symbol right here as a circle with a through it. Nothing. And ta-da! Empty set. There's nothing. The empty set is considered a subset of every set. So if I were to ask you, hey, what are all the subsets of a set? You need to include the empty set in there. Also, when you're finding a subset, you need to include not only the empty set, but you also need to include the set itself. So a subset is any set that you can make from the things in here. Think of your set as a basket. And you want to figure out, hey, what are ways that I can not rearrange, but I can like take things out and put back into my basket. So if I took everything out, I would have an empty basket. That counts as a subset. If I put back just the 3, that counts. Just the 4, that counts. If I put everything back in, that counts. Notice that I've arranged my subsets according to how many things are inside. These guys have 0 things inside. These subsets have 1 element inside. These subsets have 2 elements inside. And these subsets have 3 elements inside. That's just to help me remember that I've gotten them all. If you want to just list them out like in one big old line like this, that's great. Make sure you separate them with commas, though. Okay. So notice they're separated by commas. Come on, guys. Okay, cool. We're almost there. So we've got subsets, we've got the empty set, we've got how to write what's inside of a set. Now we need to pay our highest compliments to the chef. But we'll get there. Before we can talk about compliments, let's talk about the universe. So the largest set we're using, we call the universal set, because everything belongs in the universal set. Also because you guys are stars. Aww. Then, outside of that, the complement of a set, I should use a new color, red. The complement of a set is everything that's not in that set. So it's all the things outside of the set. We call it a not, because it's not, or a prime, whatever, because they're not inside of it. Okay, so if we wanted to represent the set A, the set A is all of these things right here inside of the set. Yay! So set A is represented by this picture. Set A. And then the complement of set A is everything outside of it. It's all these guys. And I'm not going to color it very well, but I think you get the idea. Yay. Okay, now you see this guy right here? You see this absolute abomination? That's not okay. There is nothing that exists outside of this universe. Ta-da! Okay, everything has to be within our universe box. And I also understand that my coloring was not perfect, but just, it all fits in there. Okay, cool. So that's the complement. Now, let's get some chess knowledge going on here. Let's let the universal set be king, queen, bishop, knight, rook, and pawn. Well, sorry. So each of these chess pieces. And now let's say that set A is the set of chess pieces that move side to side. Okay, so the chess pieces that move side to side will be purple. The king can move side to side, so the king is in there. The queen can also move side to side. The bishop is a diagonal guy, so he goes outside. Oh, the knight does this weird, like, hoppy thing. He can't go side to side either. The rook can. That's like the rook's jam. He only goes side to side. And pawns cannot. Pawns have to travel diagonally. Pawn. But they can go forwards and backwards, but that's not side to side. Well, they can't go backwards. They can go forwards or they can go diagonal forwards. So, that's limited. Okay, nice. What's the complement of set A? Well, the complement of set A is everything that's not in set A. So if A is the things that move side to side, that's equal to, I'm going to abbreviate, okay, king, queen, and rook. Okay, that means the complement of A is everything else, which is the bishop, the knight, and the pawn. There you have it. Okay, so our complement is what's outside of A, everything outside, and then A is, the things that we describe, what's inside of A. Ta-da! Should we give the queen a crown too, just for funsies? Just for funsies. Sweet. Okay, there you have it. Sets have elements inside of them. And then what's not inside of them, we call their complement. Yay! Remember to include your empty set. Your empty set and the set itself when talking about subsets. And have a wonderful time on your homework.